For decades, astronomers believed they had solved one of the greatest mysteries in the universe. At the very center of the Milky Way lies Sagittarius, a star, a colossal object with a mass more than 4 million times that of our Sun. Scientists have long considered it a supermassive black hole, the gravitational monster that anchors our entire galaxy. But what if that assumption is wrong? Recent research and observations have led some physicists to ask a shocking question. What if Sagittarius A star isn't actually a black hole at all? What if the object at the heart of our galaxy is something even stranger, something that challenges our understanding of gravity, space, and the laws of physics themselves? In this video, we'll explore why scientists are questioning one of astronomy's biggest assumptions, what evidence supports the black hole theory, and what alternative explanations could change everything we know about the Milky Way. Because if Sagittarius A star isn't a black hole, then the universe may be far stranger than we ever imagined. Before we can understand the controversy, we need to understand what Sagittarius A star actually is. Located approximately 26,000 light-years from Earth, Sagittarius A star sits at the very center of the Milky Way galaxy. For decades, astronomers observed stars orbiting an invisible object in this region. These stars were moving at incredible speeds, suggesting that an enormous amount of mass was concentrated into a surprisingly small area. By carefully tracking these stellar orbits, scientists calculated that something with more than 4 million solar masses was hidden there. The object itself couldn't be directly seen because it emitted very little light. Instead, astronomers detected powerful radio waves and energetic emissions coming from the region. The evidence seemed overwhelming. A compact object with immense mass and powerful gravity matched the description of a supermassive black hole almost perfectly. Over time, Sagittarius A star became one of the strongest pieces of evidence that supermassive black holes exist throughout the universe. For many scientists, the case appeared closed. But science is never truly settled, especially when new observations reveal unexpected surprises. The black hole explanation wasn't based on guesswork. It was supported by decades of observations. One of the strongest pieces of evidence came from stars orbiting extremely close to Sagittarius A star. Some complete their orbits in only a few years, moving at thousands of kilometers per second. Such motion can only be explained by an incredibly powerful gravitational source. Then came a major breakthrough. In 2022, the Event Horizon Telescope released the first image of Sagittarius A star. The image revealed a glowing ring surrounding a dark central region, remarkably similar to predictions made by Einstein's theory of general relativity. To many people, this image seemed like definitive proof that Sagittarius A star was indeed a black hole. But science doesn't stop after a single image. Researchers continued analyzing the data, comparing observations with theoretical models, and searching for inconsistencies. As they dug deeper, some scientists began noticing details that didn't perfectly match expectations. And that's where the mystery truly begins. Despite the strong evidence, Sagittarius A star behaves in ways that still puzzle researchers. One major mystery involves its activity level. Compared to the supermassive black holes found in other galaxies, Sagittarius A star appears surprisingly quiet. Given its enormous mass, scientists expected it to consume more material and produce stronger emissions. Instead, it often appears relatively calm, with occasional bursts of energy that are difficult to predict. Another challenge comes from theoretical physics. According to general relativity, matter crossing a black hole's event horizon should disappear from the observable universe forever. However, this creates conflicts with quantum mechanics, leading to the famous black hole information paradox. Some researchers argue that these paradoxes suggest our understanding of black holes may be incomplete. If the mathematics describing black holes breaks down under extreme conditions, perhaps objects like Sagittarius A star aren't exactly what we think they are. These unresolved questions have inspired scientists to explore alternative possibilities. If Sagittarius A star isn't a black hole, what could it be? One possibility is a hypothetical object known as a gravastar. Instead of containing a singularity surrounded by an event horizon, a gravastar would consist of exotic forms of energy compressed into an ultra-dense sphere. From a distance, it could look almost identical to a black hole. Another proposal involves boson stars. These theoretical objects would be made from exotic quantum particles rather than ordinary matter. They could produce intense gravitational effects without requiring a true event horizon. Some physicists have even suggested that Sagittarius A star could represent entirely new physics that has never been observed before. The fascinating part is that many of these alternatives can mimic the behavior of black holes so closely that distinguishing between them becomes extremely difficult. This means that even if observations seem to support the black hole model, they may not completely rule out other possibilities. Fortunately, astronomers are developing new tools capable of testing these ideas. Future generations of telescopes will observe Sagittarius A star with greater precision than ever before. Researchers hope to capture sharper images, monitor the movement of nearby stars in unprecedented detail, and study how matter behaves in the object's extreme gravitational environment. Scientists are also investigating gravitational waves, ripples in space-time produced by massive cosmic events. These signals could reveal subtle differences between black holes and alternative objects like gravastars or boson stars. The next decade may provide answers that were impossible just a few years ago. If future observations perfectly match black hole predictions, confidence in the current model will grow even stronger. But if unexpected deviations appear, astronomy could be on the verge of one of the biggest scientific revolutions in modern history. Sagittarius A star remains one of the most fascinating objects in the known universe. The evidence strongly supports the idea that it is a supermassive black hole, yet some unanswered questions continue to inspire alternative theories. Whether it turns out to be a black hole, a gravastar, a boson star, or something completely unexpected, the search for the truth is what makes science so exciting. Every new observation brings us closer to understanding the mysterious object hidden at the center of our galaxy. And perhaps one day, Sagittarius A star will reveal secrets that completely transform our understanding of space, time, and reality itself. If you enjoyed this exploration of one of the universe's greatest mysteries, be sure to subscribe to SciTech Signal for more fascinating discoveries, space documentaries, and cutting-edge science content. Don't forget to like the video, share your thoughts in the comments, and let us know what you think Sagittarius A star really is. Thanks for watching, and we'll see you in the next journey through the cosmos.